So 2 fans volunteer, and they're attached together with a bungee cord. So the first thing we do is draw a picture. One fan runs along the sidelines, and the other at the runs at the 50-yard line toward midfield. So the hardest part with this one is drawing the picture.
Yeah.
Okay. So here's our football field, right? And on the sideline at the 50-yard line. So here's the 50-yard line, right? And here's our people. Okay. So they start there. One fan runs along the sideline. So this person's going to run this way. Okay. And the other runs at the on the 50-yard line towards midfield. So this person is running this way. Okay. So because I don't know football very well, I actually really had to draw the picture. Like I had to like really be thoughtful about this because it didn't make sense to me until I actually know football. No. I know, but until I I'm thinking like midfield. Where's that?
I understand what you're saying, but like, it's just confusing. Well, I mean, if you didn't know that midfield was.
It's just, yeah, it was like at first I literally had to draw the whole football field to think about it. But does that make sense that this is where they're going? So they're attached with a bungee cord. So at any point, there's going to be this bungee cord in between them, right?
Oh, that's how. Do you think that you like get caught in one of them does the backflip?
Probably, yeah.
You never seen that before?
So we'll say this person is now here, and this person is there. And they've just formed this triangle with their bungee cord. Okay.
Oh, that's crazy.
So,
I love your.
Isn't it great?
That's a big bungee cord.
Yes. All right. It's like those workout classes. Have you seen those workout classes where people they're attached to a bungee cord and then they anyway. Yeah, all over they. Yeah, they have to run against the bungee cord and then it pulls them down. That would be. All right. So let's call this person X. Or this side Y and this side Z. It doesn't really matter which you call it, but we can call it that. And then the person on the sidelines is running at 4 yards per second. So we can look at our variables. X is changing, right? Y is changing. Z is changing. What is not changing? Yeah, the dx dt is not changing because this person's always running at 4.
You say Z is changing?
Yes, because it's a bungee cord, so it's stretching. And dy dt is also not changing. Dy dt is constant. And that is 3. Thank you. I know I had it and I can't see it for a minute. Okay. And so then we have to ask ourselves, what are we looking for?
Is Y changing? Oh yeah, sorry.
Yeah, no, you're fine. You're fine. That's why I write everything down because it helps me just really think about what's changing, what's not changing. Okay, and so then I need to find the rate the bungee cord is being stretched. Okay. So that is dz dt. Does that make sense that that's dz dt? Because anytime we see rate, we're talking about calculus here. Okay. All right. And so then our freeze moment. We freeze it when the sideline runner is at 30 yards. So when x equals 30, right? Because that's our sideline runner.
No, 20.
Oh, thank you. Thank you. They read it better than I did. Our freeze moment is at x equals 20 because how far did they run from the 50? Yep, I just saw the 30 and just wrote it down. Didn't even think. Yeah, when the sideline runner reaches the 30-yard line because that would be from 50 to x would be at 20. Okay? So we need to figure out how the things, we need to write an equation for the things that are changing and how they're related to each other, right? These three things are changing, so we need to relate them to each other. So that's what our equation is. How are x, y, and z related to each other? They're a right triangle, so
X squared plus.
X squared plus Y.
okay, they're related to each other that way, right? Okay, since we know how they're related, now we find our derivative because we're talking about rates of change and we're trying to figure out how these are changing. So this would be 2x dx dt plus 2y dy dt equals 2z dz dt. Okay, so then now I'm on to the solution because this tells me how fast everything is changing, right? I could solve for whatever I wanted. So let's plug in everything we know, and since we're finding dz dt, when we solve, this should be our only variable that's left.
You don't have enough stuff.
I don't have enough stuff, so that's what we're going to figure out what we still need. Yeah, because a lot of times people don't realize they don't have enough stuff until they get to this solving spot. So we figure out, do we know x at our freeze moment? Yeah, so that's 40, and then we know dx dt because it's constant, which is 4, plus 2y, and then we know dy dt is 3, and then 2z dz dt. Okay, so we've plugged in everything that we know, and now we have to figure out what else we don't know at our freeze moment, okay? So we need to know y and z at our freeze moment, don't we? So we have to find time. We have to figure out how long did it take for this guy to go 20 yards? 5 seconds, because he's going at 4 yards every second. And so it took him 5 seconds to go 20 yards. So when this guy is 20 yards, this guy would have also run for 5 seconds, right? So how far did this guy go? He went 15, right? Because we have to look at the time. At our freeze moment, y is 15. Does everyone understand where I got that 15 from, or do you want me to say it again? Find another way to say it. Yeah. So this person, they both started here, and over 5 seconds they ran, right? And the reason I know it was 5 seconds because this guy ran 20 yards.
Oh, that makes sense.
And he ran 4 yards every second. So
Yeah.
I know it has to be 5 seconds that he ran. So after 5 seconds, I know this guy's 20. And after 5 seconds, this guy's running at a constant pace. So I can figure out that he runs 15. Perfect. Awesome. So y is 15. And we also need to know z. That's where the Pythagorean theorem comes into play. 400 plus 15 squared. You guys know that one, right?
225.
Thank you. 225. So z equals the square root of 625, which is 25.
Yeah.
And a lot of you are like, oh, plus or minus, but can z be minus? No, so since we're doing a real world example here, we have to recognize that z cannot be negative because that can't happen. So we can just fill in the rest of our information at our freeze moment. We have 15 here. We have 25 here. And then all we have to do is solve for dz dt. Then it's just algebra. Do you guys feel okay with that now?
Yeah. I thought somebody said the Bungee closed out.
Yeah. I seriously, every time I do this problem, I have to draw like a picture. On this one? You have a question?
Yeah.
Okay, which part?
So I did 30 instead of 20, and I still got relatively the correct answer. Relatively.
Relatively or exactly?
I got 4.997.
And what is the X? Oh gosh. So this just happens to be one of those ones where if you make a mistake, because it's really only 10 yards, so I can see how that would, the rate of change, yeah. I remember us working on this yesterday, and I think I didn't
even tell me it was wrong.
I know, I didn't even catch it.
What the heck?
Oh my goodness. It's like I'm not perfect or something.